Welcome back to the deep dive. Today, we are tackling something really fascinating. 3I-8 It's the universe's newest interstellar visitor, and possibly, well, its most mysterious and definitely most argued about one.
Yeah, 3ITLS is a big deal. That name alone tells you a lot. It's
Yeah.
only the third object we've confirmed that comes from outside our solar system. It follows, one Oumuamua and two Borisov. So
Okay.
seeing another one swing through our neighborhood is pretty major.
Right. It was first spotted, let's see, July 1st, 2025. The ATLA survey system picked it up, and it didn't take long for the orbital calculations to come in. They confirmed what astronomers sort of suspected right away. Its path is hyperbolic.
Which means basically it came from interstellar space,
Mhm.
deep space. It's doing this wide U-turn around the sun right now, relatively speaking, and then it's gone wherever. It's not sticking around, not bound to our star.
So our mission today is to really unpack this thing for you. We want to give you the full picture. We need to lay out the initial scientific understanding, what astronomers actually know, and then we need to dive into the weird stuff, the anomalies that have sparked some really intense speculation, including, the big one, the idea that this might not be natural at all.
Exactly. We're kind of living in that interesting space between solid data and, well, what it could mean. That gap is where all the debate is happening.
Okay, let's start with the basics, the hard facts. 3I, pretty straightforward, third interstellar object. ATLS, that's the telescope system that found it. Easy enough, and for anyone worried, it posed absolutely zero threat to us here on Earth. Passes by at, about 270 million kilometers, a very safe distance.
Yeah, totally safe. And scientifically, the first look was, well, looked like a comet. We got imaging, spectroscopy data. It confirmed a coma, that fuzzy cloud of gas and dust around it. And as it got closer to the sun, it started developing a tail. The classic signs, what you'd expect from a comet heating up.
But it's more than just a light show, right? Why is finding only the third one of these so important?
Well, because each one is literally a piece of another star system, delivered to our doorstep almost. It's a direct sample of material that formed somewhere completely different. Astronomer Chris Lintott put it really well. He said something like, these sorts of interstellar objects are the most common macroscopic objects in the galaxy. The fact that we've only found 3 of them is quite fun. Which, yeah, it really highlights how rare these encounters are for us. Makes each one incredibly valuable scientifically, like a time capsule from another star.
And do we know where this time capsule came from? I heard something about it being ancient.
We have a good idea, yeah. Tracing its path backward suggests it originated way out in the Milky Way's thick disk.
Mm-hmm.
So for listeners, the thick disk is generally older, more spread out, slower moving stars compared to the thin disk where our sun lives.
Okay, so if our solar system is like a relatively young, bustling suburb,
Mhm.
this thing came from the really old, historic downtown district of the galaxy.
That's a pretty good analogy, actually, yeah. And that origin implies this object could be incredibly old, maybe 7 billion years old. It likely formed around a star, that star died, and this object just kept going, cruising through the galaxy for billions of years until, our sun's gravity pulled it in for this brief visit. So it gives us a peek into a star system potentially vastly different and much older than ours.
Okay, so that's the baseline science, an old, interesting comet from far away. But this is where the story takes a turn, isn't it? Because 3I Atlas started doing things or showing things that weren't so easy to explain, things that really opened the door for, let's say, more creative theories.
Exactly. The first oddity was its speed and path. Its hyperbolic excess velocity, basically how fast it was going beyond what the sun's gravity would dictate, was high. Maybe unusually high, even for an interstellar object.
But the path itself was the really eyebrow-raising part.
Yeah, the trajectory. It passed surprisingly close to the ecliptic plane. That's the flat disk where most of our planets orbit.
Ah.
And it made these notably close passes by Jupiter, Mars, and then Venus. Some people immediately pointed out that seemed, well, a bit too convenient. Almost non-random.
Okay, weird path. Then came the chemistry, right? And that's where things got genuinely strange.
Oh, yeah. The composition. Spectroscopy showed its chemical makeup was atypical. Comets in our solar system, usually very rich in water ice, H2O.
Yeah.
3I-8 though, had a really high ratio of carbon dioxide KO compared to water, much higher than usual. That points to it being formed in maybe a much colder environment, or just having a different mix of ices.
But that wasn't the weirdest chemical part, was it? There was something about nickel.
Right. That grabbed the headlines. Reports suggested it was emitting nickel, but apparently without the expected amount of iron that usually accompanies it in meteorites and asteroids. And then the real bombshell. Nickel tetracarbonyl. You got to help us understand that one. That sounds industrial, not spacey.
Yeah, it's really not something you expect to find floating free in space at all.
Nickel tetracarbonyl it's a toxic volatile compound. And here on Earth, it's almost exclusively linked with industrial processes. Specifically, refining nickel metal. It's just not something that typically forms naturally out of the cold vacuum of space.
So yeah, that's a huge question mark. How does a 7 billion-year-old rock from another star system end up spewing out something linked to industrial refining?
Exactly. And on top of the chemical puzzles, there were visual oddities too. Some early observations hinted at maybe an anti-tail or just a strange shape to the coma and tail. Not quite standard, so you take all these anomalies together, the path, the speed, the weird chemistry, the visual quirks, and suddenly you have this vacuum. A space where the standard, it's just a comet explanation, starts to feel maybe a little strained.
And guess who stepped right into that vacuum?
Astrophysicist Avi Loeb from Harvard.
Yep. He had already made waves suggesting the first interstellar visitor, Oumuamua, might have been an alien artifact, like a light sail. And he was definitely ready to apply that same kind of thinking to Three-Eye Atlas.
Loeb's whole approach is basically, if the natural explanation requires too many unusual coincidences, maybe we should seriously consider the unnatural one. And for 3A Atlas, his main point was its acceleration.
Right, the non-gravitational acceleration. It wasn't just following the path gravity dictated. It seemed to have a little extra push.
Exactly. And Loeb basically asked, could that push be an engine? He framed it as potentially a technological signature of an internal engine, something artificial providing thrust.
He also jumped on the visual appearance, didn't he? The lack of a big tail initially.
Yeah, you made a big point of that. It was bright. But at first, it didn't seem to have that classic long, dusty comet tail. He famously called it finding a zebra without stripes. His quote was something like, insisting that 3I Atlas must be a comet is unwise because it does not exhibit a cometary tail.
And the color. There was something about it turning blue.
That too. It was described as turning an unusual shade of blue. Loeb threw out possibilities, maybe the glow from a hot engine or some other artificial light.
So you combine the acceleration, the weird chemicals sounding like industrial byproducts, the odd look.
And the trajectory. Loeb argued that the path lining up near the ecliptic, buzzing past key planets like Jupiter, Mars, Venus, looked less random and more like, well, a planned route.
Yeah.
He called it potentially a deliberate mapping mission to check out our solar system.
And didn't he add something about it hiding behind the sun?
He did. He pointed out that its path took it behind the sun from our viewpoint for a while, which, he noted, would be the absolute perfect time for an intelligent probe to make a secret course correction without us being able to watch.
Wow. Okay, so that whole package engine, mapping mission, secret maneuvers, weird chemicals, that's what really sent the online speculation,
Right.
well, into hyperdrive, right?
Absolutely. Theories exploded. Was it some kind of self-repairing alien mothership dropping off smaller probes? Or even more extreme ideas, like was it some kind of technological Trojan horse? The speculation went everywhere.
Okay, but let's pivot back. Because while all that was happening, the mainstream astronomical community was pumping the brakes. Hard.
Very hard. The consensus view, backed by most astronomers and organizations like ESA, was much more cautious. Michael Kuppers from ESA put it bluntly, it looks like a comet and it behaves like a comet. There's no reason to think it's something else. Pretty clear stance.
So we need to go back through those anomalies and hear the standard scientific explanation. Let's start with the big one, the non-gravitational acceleration. If it's not an engine, what is it?
It's actually a very well understood cometary process. It's just that 3I Atlas might show it more strongly because of its specific makeup. The sun heats the comet. Ices on the surface don't melt into liquid. They turn straight into gas. That's sublimation, especially volatile ices like the carbon dioxide that 3I Atlas seems to have lots of. This gas shoots off the surface, and just like a rocket exhaust, it pushes the comet slightly. It's a tiny natural thruster effect. So the high CO level explains the extra push. No engine needed.
Okay, so the weird chemistry actually explains the weird movement. What about the look? The zebra without stripes and the blue color.
Well, the initial lack of a big tail. That's likely just because it was still quite far from the sun when first observed. It hadn't heated up enough yet to really get going. Later observations as it got closer did confirm it developed a coma and a tail, just like a comet should. And the blue color, that's physics too. It's consistent with sunlight scattering off very fine dust particles or potentially specific gases being released, like maybe molecular carbon. Blue light scatters more easily than red. So an exotic blue, yes, but a naturally explainable blue.
All right, but the nickel tetracarbonyl.
That still feels like the toughest one for the natural explanation.
Yeah.
Industrial chemical in space. That's definitely the most puzzling piece. But astronomers think it's likely down to the very unusual natural chemistry happening under conditions unique to an interstellar object. Conditions different from our own solar system's formation. The exact process isn't fully pinned down, but the idea is that as nickel atoms came off the comet nucleus through sublimation, they might have reacted in the gas cloud, the coma, in unexpected ways in that extreme environment. It's evidence of alien chemistry, chemistry that happens differently around other stars, not necessarily alien industry.
Okay. And finally, that mapping mission trajectory. Passing Jupiter, Mars, Venus, staying near the ecliptic still sounds a bit fishy for pure chance.
This really comes down to statistics, or rather, the lack of them. Yes, the path is interesting. It's an outlier, perhaps. But is it impossible statistically? No. And the crucial point is, we've only seen 3 of these interstellar objects. Ever. We simply don't have enough data to say what a normal trajectory for an interstellar visitor looks like. Maybe many of them do come in near the ecliptic plane for some reason we don't understand yet, or maybe this one just happened to. With a sample size of 3, you can't really draw strong conclusions about what's normal or random. Finding an outlier first isn't unexpected.
So the scientific consensus lands on the weird chemistry, the high CROs, aren't signs of tech, but actually proof that it comes from a very different, ancient natural environment, making it incredibly valuable for science.
Exactly. It's a priceless sample of alien geology and chemistry, precisely because it's different. And this whole episode, this whole debate, really highlights how science works, right? You have the observable data, but then there's this gap in interpretation. And that gap fuels both rigorous scientific investigation and wider cultural fascination. Loeb himself said something like, "Science is work in progress, where multiple interpretations must be entertained," which is fair.
But that gap, that uncertainty, it also gets filled with other things too, doesn't it? Like misinformation and conspiracy theories.
Oh, definitely. That happened almost immediately. You saw claims of data suppression flying around. Lowe mentioned he tried to get specific images, say from the HiRISE camera on the Mars Reconnaissance Orbiter, and apparently didn't get a response or access. Now, there could be many reasons for that, but it immediately fed the narrative for some people that evidence was being hidden, a cover-up.
And then the outright fakes started appearing too.
Yeah, that was wild. We saw deepfake videos surface using the likenesses of well-known scientists like physicist Michio Kaku, making it seem like they were endorsing the alien probe idea. It just shows how easily manufactured narratives can spread when people are looking for definitive answers, especially exciting ones.
It really became this interesting cultural moment, didn't it? You had the sort of exciting, easily digestible alien tech explanation versus the more complex, nuanced scientific one involving sublimation and statistics and exotic chemistry.
And the nuance explanation is always a harder sell in the modern media landscape, you know.
So, wrapping up this deep dive, what's the synthesis? What should you, listening, take away from all this? It feels like 2 valid, though competing storylines emerged.
I think that's right. On one side, you have the overwhelming scientific evidence pointing towards this being a natural object. An ancient interstellar comet, yes, but one with unusual features that simply reflect its origin in a vastly different stellar system. It's proof of cosmic diversity, really.
But on the other side, the anomalies were real. The acceleration, the composition, the trajectory, they were unusual enough to push scientists. They forced astronomers to really test their models, to explore the edges of known physics and chemistry. And they kept that door, that what-if possibility, just slightly ajar, which is also part of science.
Yeah, and the whole event is a perfect case study in how we process mystery, how we deal with speculation versus evidence, especially when it involves something as profound as our place in the cosmos.
Okay, so here's the final thought we want to leave you with. Think about this. 3I Atlas. This chunk of rock and ice, potentially 7 billion years old. It's literally a fossil from another solar system's birth. We got this fleeting glimpse, this tiny sample, of how planets might have formed around another star, a star that likely died long, long ago.
It's incredible when you think about it that way. And this encounter, brief as it was, really challenges what we think is normal out there in the galaxy. We found 3 interstellar objects now, and honestly, each one has been weird in its own way. Each one has made us rethink things. Makes you wonder, doesn't it? What surprises will the 4th or the 5th or the 10th one bring?
Subscribe for more.